All right, so we're into our last main topic now in this course, and that's going to be statistics and probability. So we're going to start out with statistics. So statistics is an important part of everyday life. I mean, you see it right now. We're going through this COVID-19 pandemic, and that's all you see every day is statistics, right? Okay, number of new cases, number of deaths, number of hospitalizations, number of ventilators, all that kind of stuff. That's all statistics. So it's important whether you're starting a business, deciding how to plan for your future, or watching just the news, because in addition to all these COVID statistics, we're going to be bombarded with all these election statistics coming up in the fall, right? Assuming the COVID situation has calmed down. So, statistics come up in everything from opinion polls, economic reports, to the research on cancer prevention, and also to the research on this COVID 19 vaccine and treatment and all that stuff. So it is important to know statistics. Now, generally speaking, statistics involves three things. That's not written on this PowerPoint, but you're really collecting data, you're organizing data, and then you're analyzing data. Now, in this particular course, we're really going to focus mainly on the organizing of data. If you take an actual statistics class, then you'll do, probably the collection on your own potentially. You'll also organize it and then you'll also analyze it though. Okay, so we're going to focus mainly on the organizing in this course. And in general, we have two different types of data. We have what we call qualitative data, which can consist of attributes, labels, in general non-numerical values. All right, so things like gender, eye color, ethnic group, telephone number, those are all qualitative. And the reason that telephone number actually falls under qualitative and not quantitative is you might argue, well, a telephone number is a number, so it's quantitative, right? Because quantitative is going to be our numerical measurements. But the difference is when we think in terms of telephone numbers, do we think in terms of like an order to them? Like is, 555 1265 less than 862 9357? No, they're just different telephone numbers. So it's not something that you're going to be putting into any kind of order. Therefore, a telephone number you would still think of as qualitative. But quantitative is going to be anything that you think of as numerical where order is important, right? Okay, like 1 is less than 2, right? 5 is less than 8, things like that. So age, height, weight, number of classes taken, those are all examples of quantitative data. All right, so how are we going to organize the data? And this is what I had said, right? We're not going to do the collecting or the analyzing. We're going to generally deal with the organizing of the data. So what we can do is count up what we have. All right. So just a couple definitions before we get into the actual graphs and things. All right. This this symbol here, this is a Greek letter called sigma. We've actually dealt with this in a previous lab, and it really means that you're adding up, right? Summation of values. So when you see that sigma symbol, it really means you're adding up a bunch of values. Now, lowercase f is going to stand for frequency, and it's just going to be how many times it occurs. So that's going to be your f. And then what happens is if you add up all the f's, you get your total number of pieces of data, okay? So that's what lowercase n means. Lowercase n just means the total number of the data entries. And the relative frequency, which is going to be denoted RF, is just going to be the portion or the percentage of the data that falls into a particular class. So in other words, is of a certain type. So a class is just the specific piece of data. So if it's quantitative data, one class might be 2, another class might be 4. Okay, if it's qualitative data, one class might be male, one class might be female. Okay, so the classes are just the specific pieces of data. So if you want to find a relative frequency of something, you just divide its frequency by the total number of data entries. So you do f divided by n, right? Where n again is the total. And then what we're going to do is we're going to create bar graphs and histograms, and bar graphs are going to be used for qualitative data, and histograms are going to be used for quantitative data. And since we're online, it's going to be difficult for me to have you create bar graphs and histograms, so I'm basically just going to be, for the most part, asking you to analyze them, right? So I'll give you a bar graph or a histogram, and then you'll have to give me information about what it's telling you. So that's just basically some vocabulary: sigma, frequency, relative frequency, class, bar graph, and histogram. So here we have some data. We have data on 15 different cereals. So they're organized by manufacturer, how many grams of fat they have per serving, and how many grams of sugar they have per serving. So we actually have three separate variables here. So we might want to call this one variable 1, that one variable 2, and that one variable 3. Why are they variables? Because they change, right? The manufacturer can change, the number of grams of fat can change, and the number of grams of sugar can change. So fat and sugar, those are actually going to be quantitative because those are numerical, where you can order them. You can say, all right, well, this cereal has less fat than this cereal and has less fat than this cereal, so on and so forth. Whereas with qualitative, there's no ordering involved. It's just names of the manufacturers. So the qualitative value is going to be the manufacturer. So now if we were going to create a frequency distribution table for that qualitative data, what we'd have to do is we'd have to count them up. And we'd have to say, all right, well, how many Nabiscos do we have? How many Kellogg's do we have? How many Posts do we have? And how many General Mills do we have? So generally we would create a table. So here's my table. And what I would do is I would just create labels for the columns. So I would call the first column label the manufacturer, and then I call the second column label the frequency, and then I just list the four manufacturers. So I have Nabisco, Kellogg's, Post, and General Mills. And then what I could do is as I go through the different cereals, I can keep a tally of how many of each I have, right? So what I would start doing is I'd say, all right, so I have Nabisco, then 2 Kellogg's, then a Post, then 3 General Mills, then a Nabisco, then a Kellogg's, then 3 Posts, then a Kellogg's, then 2 General Mills. So that's what I have all together. And then I would go and take those tallies and insert them into the frequency column for each one. So 2 Nabisco, 4 Kellogg's, 4 Post, and 5 General Mills. And then you just want to make sure that, remember what we had said on the previous page about the sum of the frequencies? The sum of all the frequencies should be n. And in this case, when I add up 2 plus 4 plus 4 plus 5, I get 15. So that actually is equal to my total number of data entries. So that would be my frequency distribution table. And then now if I was going to use this to create a bar graph, I would set something up like this where I'd have my two axes, right? I'd have my frequency as like my y-axis, and on my x-axis I just have the different cereal manufacturers, and I would give it a title that I'm calling cereals by manufacturer. So in other words, how many cereals are there for each manufacturer, and then I would just create bars above each cereal manufacturer name. So the Nabisco would have a bar that would go up to 2, so it would be something like this. The Kellogg's would go up to 4, so it would be like this. The Post would also be 4, so it would be the same height, and the General Mills would be 5. And that would be your bar graph. Okay, so you have 2 for Nabisco, 4 for Kellogg's and Post, and then 5 for General Mills. And with bar graphs, the individual bars don't touch each other, right? They're separated. When we do histograms shortly, those bars will actually touch because that data is going to be ordered, right? It's going to go in an order. Whereas Nabisco, Kellogg's, Post, and General Mills, there's no order to those. They're just qualitative labels. Okay, so that would be your bar graph for cereals by manufacturer. So moving on now to our quantitative variables, right? We had said our manufacturer was our qualitative variable, so that leaves fat and sugar as our quantitative variables. All right, so we're gonna look at these individually, right? We're gonna look at the fat and sugar individually. So we'll prepare a frequency and relative frequency distribution table for the quantitative variable sugar. We'll again set up our table as we did before. So we can see in this case, I have my column set up as sugar in grams, the frequency, and the relative frequency. So I can do the same thing I did before with my manufacturer. I can go down the sugar column and make tally marks at each of these numbers from 0 to 6. So there's a 6, a 5, a 0, a 5. So I would just go down and make my marks. 1, 3, 2, 0, 3, 5, 3, 4, 6, 3, 6. And now I would just fill in my frequency column based on the tally marks I created, right? So there's my frequency column, And remember what I had said before, you just want to make sure that the sum of the frequencies is n. So if I add up 2 plus 1 plus 1 plus 4 plus 1 plus 3 plus 3, that does equal 15, and 15 is my n, so that's good. And now with relative frequency, simple. All I do is I just take my frequencies and divide by n, which is 15. So, I mean, it's nice to put them into like a percent form, but you can just leave them as a fraction if you really want to. So it would look something like this. Or you could turn it into a percent. So you would just do your division and then move the decimal over 2. But in most of these cases, you'd have to round. So like 2/15 isn't going to be a nice perfect percentage. So you just round it to like the nearest tenth of a percent or something. So if you do that, you get something like this. Okay, so 2/15 ends up being 13.3%, 1/15 is 6.7%, 4/15 is 26.7%, and 3/15, that's the only nice one because it's actually 1/5. It's actually 20%. So all those relative frequencies, we didn't say this earlier, I don't believe, but all the relative frequencies should add up to, right? So if we do sum of the RFs, that should equal 1 or 100%, right? So if I add up all the fractions, it's clearly 15 over 15, which is 1. If I add up all the percentages, I technically get 100.1% because of rounding, but it's essentially 100%. So that's what you want to make sure. So that is your frequency and relative frequency distribution table, and you can combine that into a single table. All right, and then what you would do is you would just use that data then to create a histogram. So I'll create a frequency histogram. I would set something up like this where I'd have my sugar grams on the x-axis and I'd again have my frequency on the y-axis. But now the difference is, since this is a histogram and 0 flows into 1, flows into 2, flows into 3, right, it's ordered, I'm going to make my bars touch, okay? And I just labeled this sugar contents of cereal, right? That's what I gave it as a title. So I'll put my bars in. So there's my frequency histogram. And again, the key is that the bars touch. And you want to do as good a job as you can in making the bars be the same width, right? I mean, it looks like my bar for 3 grams is a little bit wider than the other ones, and the bar for 0 and 4 is a little bit narrower than the other ones, but you just try to do the best you can and make them the same width. But realistically, when you're doing this, for like a real project, you would do it on computer software. So the computer would basically make it look pretty for you. You just have to enter the data and then it would construct it for you, which is another reason why I'm not really going to have you do these. You're just going to basically be looking at them and then have to answer questions about what they mean. So that's your frequency and relative frequency distribution table, and then your frequency histogram for your quantitative variable of sugar.